Hi, this is Mrs. Carnes. This time we're going to be looking at the angle, side, angle, triangle congruence. And so you're probably very familiar with the way this is working. We just finished up with side, angle, side, or you can go back and view that video if you need to. And we talked about, in that case, it was an angle that was included between two sides. And in this triangle congruence, we're going to be looking at the side that is included between two angles. So let's take a look here at our triangle ABC. If I was to take a look at angle A and angle B, then the side that is included between the two of them would be side AB. It's basically the side that connects the two angles. There's another way of looking at it. We could also take a look at two different angles, like let's say angle A and angle C, then the side that would be included between those two angles would be side AC. And so it's basically, again, that side is going to be the side that connects those two angles together. We really want to make sure that when you're using angle, side, angle, you have to make sure that that side is the included side. And you'll see why in the next video. So the angle, side, angle postulate, or ASA, it states if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then those triangles themselves will be congruent. So basically it's just like the picture shows. We have angle B is going to be congruent to angle E, so there's one angle. We have angle C is congruent to angle F, so there's another angle. That means I have my two A's. Now I'm looking for an S to be able to use angle, side, angle. We know that segment BC is congruent to segment EF. Now, the only thing we had to check is that side included between those two angles? And yes, it is. There's angle B and C, and the segment is in between them, or included. So again, we could easily state that triangle ABC is congruent to triangle DEF by the angle, side, angle postulate. So let's take a look at another proof then. We've been given the information that angle M is congruent to angle P and that N is the midpoint of segment MP. They're asking us to prove that triangle LMN is congruent to triangle OPM. So like always, like we've been doing, we want to start with our given information. So I'm going to state first of all that angle M is congruent to angle P. And the reason that they're congruent is because that was given information to us. I also want to mark my picture. Angle M and angle P are congruent to each other. The second piece of information that's been given to us states that N is the midpoint of segment MP. Now that's not really a side or an angle that are congruent to each other, but what that information gives us is it does tell us then that if N is the midpoint of segment MP, then we know that segment MN is going to be congruent to segment PN, because by definition of midpoint, it's cut into two equal pieces. So our statement would be segment MN is congruent to segment PN. And the reason is not given because we were told that N was the midpoint of segment MP. What we want to actually say is by definition of midpoint. This proves that they're equal because a midpoint is going to be in the middle of that segment. It's cutting it into two equal pieces. Now, both of these are going to be sides or a side and an angle. This is an angle, and this is a side. And so we know that we either need, well, in this case, we have to have another angle. So we look at our picture because there's nothing else that's been given to us, and we see vertical angles. And so I'm going to go ahead and I'm going to mark that my angles are congruent here because they're vertical angles. Now, because their N refers to two different angles, I have to actually list this out a little bit differently. So I'm going to say angle LNM is congruent to angle ONP, and the reason is by the vertical angle theorem. We've seen that one before. And that we know then is our other angle. Now we have two A's and an S. Now the only thing we have to check is that S, is that side included between those two angles. And when I look at my picture, triangle LMN, here's an angle, and that side is included. Same thing on the other triangle. The side is included between those two angles. So I can now have enough information that I can go ahead and state that triangle LMN is congruent to triangle OPN by the angle side angle postulate. And so that tells us then that those two triangles are congruent, and we proved what we set out to prove. Remember, this should be your last line of your proof. Whatever they ask you to prove should be the very last thing that you have down there. Okay, excellent job. Again, if you want to get really good at these proofs, you have to keep practicing them over and over again. There's going to be a few more videos that are going to show you more examples of this, so keep watching.